Hi, my name's Chuck Durfee, and I'm going to be running you through the bowling game code kata using Java and JUnit, the classic implementation. A code kata is a coding exercise that you perform over and over in order to get it ingrained in your way of doing work. This one teaches test-driven development and was conceived by Robert C. Martin. So we're going to be talking about test-driven development here. This particular kata, you start out with a blank Java project. We're looking at Eclipse Luna right now, and as you can see, there's nothing there. Let's go ahead and create something. I'm going to start by creating a JUnit test case called game test. And this can be anything you want it to be. I'm just picking a pretty generic name. I am interested in the setup and teardown method here for reasons that will be shown in a second. Notice the JUnit4 is not on my build path. It's going to offer to add that for me. Awesome. Here we go. The first thing I want to do is I want to make sure that my test runner is working correctly. So let's go ahead and do that. And as you can see, I got the not yet implemented exception that is due to this assertion. That's perfect. So everything is working correctly. I've tried to record this video a few times. You may hear my dogs in the background, for example. In this particular case, or I should say the last time I did this particular one, I had goofed up the project in Eclipse and JUnit tests weren't running at all. So I recommend running this particular step even though it may seem simple. You may uncover a problem that's a lot easier to solve at the very beginning as opposed to trying to solve it much later. The most simple bowling game that you can have would be one where you don't knock any pins down. I'm going to assume that you're somewhat familiar with bowling in here, so I'm not going to describe too much about bowling. That's a lie. I'm probably going to describe how to score bowling as we go along. Let's see here. So this is assert equals, and then I just need something here. And then I'm going to say that if I don't knock any pins down, I don't score any points. And then here's the place where you put the actual implementation. I want to have a class called game and an instance of that class called game2, and I want to be able to call a method called score on that. Notice I haven't created the game class or anything yet. I'm using these tests to help drive my design. So I'm writing the code that I wish already existed, and then I'm going to go make my wish come true. I can do some stuff here in the game class first, and I want to do this because it might flesh out some construction details that would be useful to get out of the way in this first test. So during the setup, before I actually execute any of the tests, I just want to instantiate a new copy of the game class. And then at the end of each test, I want to get rid of it. The reason I want to do that is if I have a game class that has any internal state and I try to run a bunch of tests in a row, I could accidentally end up creating tests that rely on the order of execution in order to work. I don't want to contaminate my tests with previous data, so I want to create a new copy of the game every single time. Here we go. This is as far as I can take this game class without creating some infrastructure. You'll see that Eclipse is going to help me out here. It's going to want to create a copy of the game class. All of the defaults are okay. So here's a copy of the game class. Again, nothing too groundbreaking there. I also need a score method. And I'm interested right now in just getting this thing to compile. I'm not going to make it pass. But I do want to put the right signature here. I want this thing to return an integer. And null isn't a valid integer, so I'm going to pick the default integer, which is 0. It so happens that 0 is the expected result of this particular test, so I'm going to expect that this test that I just wrote is actually going to pass. Normally when you do test-driven development, while you're looking for a loop of writing a failing test, making that test pass, and then possibly doing some refactoring for non-functional reasons. And we'll talk about those as we go along, but in the parlance of test-driven development, that's known as a red-green refactor. So now we have a passing test, but this game class has not got all the functionality I would like, so I'm going to write a test that forces me to create some more functionality. The next most simple case that I can think of is one where I knock down some pins but don't do any special scoring. And then I'm going to make that happen by just knocking down one pin during each try. Bowling consists of 10 frames, and in each frame you get 2 tries, except for the very last frame, which we'll come to here in a while. But during the course of a normal game, why you don't end up with that special case. So we have 10 frames, 2 tries per frame, that's 20 total. If I try to run this test right now, I would expect it to fail. Single pin expected 20 but was 0, perfect. That's what I would expect. So now I need to go back here to my game class and make it work somehow. Well, one thing I need to do here to my test, this test isn't complete. I need to convince my game that I've actually rolled those single rolls all the time. So let's go ahead and do that. So 20 times, I'm just making a simple loop here. I need to do something 20 times. I said I wanted to roll or knock down a single pin. So I'm going to call this method roll. But you could say clobber or knock down or whatever you want here. So I'm going to create a method roll. It doesn't return anything, but it requires a number of pins knocked down. And I'm just going to go ahead and leave that I. When you score bowling, you're interested in the total number of pins that were knocked down. So I'm just going to create this sum variable that's going to contain that. And then, of course, this score method needs to use that sum variable somehow. We're just going to return it for now. So now I have this. So if I think about it, if I don't roll anything, it should return 0, because that's the default value for an integer. But if I pass 1 to it 20 times, it's going to increment the sum 20 times by 1 each. So this ought to work. Let's give it a shot. It does. Excellent. So now I've got 2 tests, and as long as you don't encounter any of the special rules of bowling scoring, this class will work as is. But I want to go a little further. I want to now be able to handle spares. So the definition of a spare is in a single frame, if you take 2 tries to knock down all 10 pins, while you get to count the first ball in the next frame twice. Let's go ahead and set up that situation here in our unit test, and then let's figure out how we want to implement that. So I'm just picking numbers out of my head here. Roll 7 and then roll 3, so that would be a spare. And then let's say the next time we roll a 4. So I would expect my result to be 10 plus 4 plus 4 again, or 18. Does spare happen to pass with the current implementation? Nope, it doesn't. So this is that red part of the red-green refactor step. You'll find sometimes that maybe your class actually does what you want it to do, and you're just writing tests in order to document the functionality of the class. We may talk about that a little bit later, but tests are more than just a way to make sure that your code's working correctly. So, in order to do spares, I mentioned in the definition of a spare that we have this concept of a frame. We don't have that yet. And I also need to be able to score the next frame twice. And I don't know how to do that because at the moment I'm not recording the rolls that I've been making. So let's start out by doing a little refactoring here. One of the rules of TDD is that you don't do any refactoring while you have failing tests. So I'm just going to comment out that test for a second, and so I have a clean slate where I can do some refactoring here. The way I'm going to keep track of particular rolls is through an array. So, and I'll just call that results, and that's a new integer 21 because that special bonus frame at the very end. I'm going to need to initialize. That's not very useful to me. I'm going to need to initialize the values in this particular array, or it's not going to work correctly. So let's go ahead and create another for loop here. Those of you who know Java really well are probably frustrated and yelling at your YouTube video right now, or your YouTube viewer right now. I apologize that Java is not my native language, but it's, again, the classic implementation of this, and it actually works out pretty well to demonstrate TDD. I want this to equal 0. There we go. So now I've initialized my array. How am I going to use my array? Well, if I'm rolling, I want to capture the results of that roll in my array. So results something, this would be the current try. I want that to be equal I, but I don't know what the current try is yet. So let's think about that for a second. In sum here, in order to figure out what sum is, I want sum to be equal to results. You notice I did some cutting and pasting there. I don't know a better way of handling a loop in Java or a good way to encapsulate this looping logic of looping 20 times. Maybe some of you guys do, and you can leave those in the comments for me. I notice here now I'm only using the sum variable in this one method, so I'm going to pull this sum method, or the sum variable, into the method itself. So that's dealt with. Okay, so my son is safely in the house, so we can keep going. All right, so we don't know what this current try is. I'm going to need to implement that. Looks like other than that, we're in pretty good shape. Oh, I haven't initialized sum, so let's go ahead and do that here. So current try, well, how am I going to figure out what my current try is? Maybe the simplest way of handling this would be to make this thing a field, and then let's just go ahead and increment it. So now I'm assuming that the users of this class are going to be recording their results in order, but I think that's okay. My test kind of suggests that they do anyway. Let's go ahead and see what we have here. Oh, the single pin game no longer works. Why is that? Oh, it's because I put an equals here instead of a plus equals. This is the reason that whenever you're doing refactoring, you always want to start from tests that work. If I had not done that and I had the spare game broken, I may not have noticed that my single pin game was broken as well, and then I'd be trying to troubleshoot two problems at the same time. In a simple class like this, no big deal, but when you are doing more complicated programming, it can be a big deal, so it's good to get in the right discipline here. Let's go ahead and try this, and then we'll run our tests again, and sure enough, they all pass. That's great. Let's go ahead and uncomment the spare game tests. I expect it to still be broken because I haven't taught the game class how to handle spares yet. I haven't even taught it what a frame is yet. So let's go ahead and do that now. Let's see. Frame. 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 And then here I have an I. What do I want to do with I? Results I plus 1. So the thing that I want to do here is I want to count both tries in the frame, but I don't know what index of the array to use. So since we're looping through these frames, let's go ahead and create a tracking variable, kind of like we did down here with roll. Oh, try is already used. Let's see, current. Let's use synonym attempt. All right, so now I could say something like int I equals attempt, or well, I could do that, but let's instead go this route and just increment attempt. And if I'm going to do that, let's do this like so. There we go. All right. Back to our game test. Still fails in the same way, which is good. Okay, so I just violated one of those TDD principles again. I should have commented out the test and done that particular refactoring, but it turned out everything was okay. I know that if I run into problems, I know where to backtrack, and you'll find that people who are experienced with TDD will often skip steps. My bad. So what is a spare? Well, a spare would be if this value is equal to 10. So now we have a spare. And for the spare, I want to capture the results of the attempt after the next one, after the two that are in the current frame. So that ought to work. And then if I go back here and try my test, everything passes. Is there some refactoring I can do here? Yes, I have some duplication that I want to get rid of. So let's go ahead and do that. Let's call this tally frame. You'll notice that Eclipse went ahead and removed both instances of that. And then I have this comment spare. When you're doing test-driven development, one of the code smells you might begin to notice is that when you're writing comments in your code, you could use an intention revealing variable name or method name instead. In this particular case, I'm going to do a method that I'm going to call isSpare. And that way I don't need this comment spare, because if you read this code, if isSpare, do this. I already know it's a spare. Okay, everything should still work in my refactoring. Let's double check. Yes, okay. Next up would be a strike test. Strike is when you get all 10 pins knocked down in the first try of a frame. And I'm changing the numbers here deliberately so that I end up with different values each time, just to make sure that I don't introduce any strange coincidences in my tests. So I always try to make sure that the data is is pretty indicative that the code is working correctly. I'm trying to build confidence in my code. So here I have a strike, and then the next two pins are free, and then we rolled gutters the rest of the game. So 5 and 4 is 9, 9 twice is 18, plus the 10 is 28. Does this happen to work today? Probably not. Let's see here. Nope, strikes don't work. Expected 28, but was 19. It didn't count these other two twice. That's to be expected. How do we want to handle strikes? Well, what is a strike? Strike is if results attempt is equal to 10. That means we had a strike. And what happens inside a strike? I'm going to move that on the inside. My apologies. What is a strike? A strike says that I want to include the results of, this one, that one, and that one. But I don't want to increment attempts by 2 in the case of a strike. That's a little annoying. So let's pull this logic out like so. And here I just want to do attempt plus plus, because I only want to increment one time. Let's take a look and see, whether that naive attempt works. It doesn't. Single pin expected 28, but was 18. Oh, I remember when I was talking about the fact that cut and paste was harmful. Here's an example. I forgot to change the alert message each time. So now if I run this, it's going to say strike expected 28 but was 18. So I didn't ever increment this guy. And sure enough, I didn't. There we go. Now let's see what happens. Everything passes. Is there room for improvement in this code? Sure. So you'll notice down here, I'm doing some incremented by tally frame, and tally frame is this right here. So I could replace this by saying tally frame of attempt, and everything should still work. And now I've got, let's split this line up in two for a reason that will become obvious here in a second. Sum plus equals that as well. So now, no matter whether I go through this if clause or that if clause, I'm going to be doing this. So let's remove this like so and just do it twice. Does this still pass? No. No, it does not. Why? Because I incremented attempt before I got my values. Let's move this up here and see what happens. Bingo, everything works. Okay, so now I have something that works out okay. I have a little duplication here. I kind of want to save that for a little bit. Let's go ahead and see what happens if I try to run a perfect game of bowling. A perfect game says that I rolled 12 strikes in a row. How do you do things in a row? You write a loop. And the perfect game is 300. What happens now? Everything passes. Isn't that interesting? So this implementation of the game, I didn't have to do anything special in order to write the perfect game. And that's part of the reason that Robert C. Martin picked this particular example, was that here you have what could be a special case, but turns out not to be. The only thing that's left here now is some refactoring. So let's go ahead and take care of that. Here is strike. That's an analogy to is spare. And then this right here, I'm going to pull this out and call it score bonus. There we go. And I think that looks like everything I want to do to this particular class. All right, thanks for listening. Have a good day.